Hey guys, how you doing? So today I am building some stainless steel wall lights and some stainless steel spike lights. I've got the backs for most, and I've definitely got the tops, etc. for the stainless steel. So first thing I'm going to get on and do is get these get the clear lenses in. So we'll take these. We'll get 2 lenses. Thanks. And we'll get the 13 by 150 O-rings on each of the lenses. A little spray of silicone. And we'll get these in. Great, thank you. There you go, that's the lenses in on those 2. I might as well, while I'm doing lenses, I might as well get all of these in. We've got, so it's 2 wall lights, 10 spike lights to do. It's quite late in the afternoon, 4:30-ish, and I need to get done fairly soon. Obviously it's got to go through all its proper testing. 6, 7, 8, 9, 10 lenses. We've got the first parts back from the injection moulding company, Travium, and the results are positive. So now they're going to build the machine for us so that we can do the injection moulding in-house. And then we'll start injection moulding these lenses and also doing the protection circuit bodies, basically these things, on that machine, and they'll do it all kind of in situ, and it'll make it a lot quicker because machining acrylic for us is quite problematic, to say the least. It's often pushes back, and yeah, it basically just doesn't work very well. I mean, the guys machined a whole bar of acrylic the other day to get some protection circuit bodies. I mean, should get about 40 bodies out of a bar, and I think they got something like 15 because there were so many that were like the wrong size and had so many issues, and the bar got kind of misshapen and all sorts of stuff. So I mean, that basically the injection moulding is to eliminate that issue. Christ knows where it's going to go. Well, I guess we'll work that out at some point. But yeah, we'll get there. So you can see these are a little bit fiddly. Not too bad. Slightly harder with cotton gloves on, but the cotton gloves are necessary because this is stainless steel. And Max has already gone to an effort of trying to clean these up. I mean, they will get a final clean up at the end, but ideally we don't get finger marks and stuff like that on it anyway, because after all the brushed finish is the kind of end finish for it. So yeah, normally I use a tool for this, but if you see this board up here, the tool is missing. And then in a sec what we'll do is we'll laser the backs and get that done. Now these new tops are designed to take glare guards. So if the customer decides, do you know what, I don't like seeing the light output from an angle, what we can do is we can machine a glare guard for them, and they can fit them themselves. The end customer could fit them. It doesn't have to be the electrical contractor or the landscape contractor. But yeah, that's the idea. So that's just an example. That's how a glare guard looks. Obviously not in green, it would be in stainless steel, and we've sized it in such a way that it will sit low enough that you're not going to get a pool of water collecting on there. So yeah, anyway, right, let's get on and start lasering the backs. I'll turn you around, bring you over here. Let's get the laser on. Pop that in place, get this positioned at the right height. So these ones are for Eclipse Electrical. Turn that off now. So I'm just waiting for the software to load up. Let me just bring you out and just show you what we're talking about. So here we have our program. I'll bring it out a little bit further because I'm not sure what the focus is like on this. Mark back a light. Ooh. Right, so the laser marking's up. We'll do red like that. We get this spinning thing going on here and then we start marking. And as you can see, it marks quite nicely. So I've got 6 lasered, so I still need to do another 6 to go. I'm just waiting for Max to finish off sanding and finishing the backs of those. So at the minute what I'm going to do is I'm going to just get on and just assemble this 6, and we'll start with the wall lights. So the first thing I need to do, and I shouldn't normally have to do this, is clean up the ball joints. Normally it's meant to come cleaned up from the machining side. I think at some point what's happened is they've just been taken from the machining side and just placed into the box over here. So yeah, I mean, we're still working on our like procedural bits and pieces to try and make sure everything runs more efficiently. And there will be a we'll be putting like a new system in place where everything kind of moves through a workflow and doesn't actually land at a station until it's ready, so that hopefully we can eliminate issues. I guess the only thing is, you know, trying not to be behind on stuff, which has happened a little bit recently, partly because we ordered some new 1 watt boards, etc., and when they turned up they had the wrong hole dimension and other bits and pieces like that, really. So you know, there's kind of things that are a little bit beyond our control, and the suppliers can only make them as fast as they can, and obviously with everything, with the current situation, everything is slower, like materials, etc., are slower to get hold of, which is, it's quite frustrating at times. But it's what it is. What can you really do about it? We're all in the same boat. So anyway, the way I do these is, so basically I just put on a little bit of Loctite on the thread, screw them in. And it just helps. The Loctite's obviously just to help set the ball joint in, so it isn't going to fall out, but you know, isn't going to work itself loose through any sort of bending or anything like that that the customer does, or you know, changing direction of fittings, etc. Because you don't want it to just fall out, obviously. What I'm trying to do things a little bit more in a process that makes sense. Sorry, camera cut off there. So now I'm just going to clean up the Loctite on the back. Not too bad. Now, you probably heard me say it before about our whole ecology or what we do about being eco-friendly, and basically using rags and things like that over buying in cloths just makes so much sense. Give something a second life for something else. You know, that clothing, if it's good clothing, it gets sold on, reused, whatever. But if it's stuff that would be rags, we try and reuse it here. Right, so hopefully these fit now. If they don't, it's going to be a pain. Oh, he says. Not fitting still. Is this one? No. Some of the teething issues that we have, because obviously this should just go together nice and easy. Where you lose a bit of efficiency. Take two on that. Right, they better fit now. They do, but now I've positioned it really badly. There we go. That's how that looks, like that. It's like a little smile, hillbilly smiley face, I like to call it. Let's get this one in. This one's a bit tighter. But it has gone in. Right, then I get a little bit of thermal adhesive in the middle, and this is to do with, for the LED, there's a little pad on the back and that goes on too. So pop that in there. There we go. That's your LED in. Also shows you how easy it is to change. Literally pop that LED out, you leave the aluminium board stays, and you literally just pop the LED board out, plug in a new one. Just literally just 3 pins, just like that. Plugs in, plugs out. Nice and easy. Okay, now I do have to do thermal tests, but just for the purpose of showing you how this all goes together. Get this on. And get a top on. Ah, my glove's stuck. I have to undo that and get it out. So that is a head for a wall light. Nice and simple. So there's a sleeve to go on these. And we've also got to do the hinge as well, so we'll show that next.